Thank you very much. Hello everyone. Mentioned I'm Adam Dangoor. Last year I was working on the back end of an iPhone app in Python, and basically the point of the app was you would take a picture of your wine bottle, the label on your wine bottle, and the app would tell you all kinds of details about the wine. And the service we used to provide the image matching was called VUFORIA Web Services. I didn't have anything to do with making it. And basically what it lets you do is upload a bunch of images to their servers, then they do some magic, and then you can upload one more image, and it will tell you, okay, which one is closest from the database of stuff you've already uploaded, which one matches most closely to the one you just uploaded now. And what that meant is that a user could send their wine to us, we'd send it to VUFORIA, then VUFORIA would give us an ID back, and we'd look up that ID in our database. Something like this. We'd make a simple GET request, get an ID, look it up in our database. But when we built our prototype, we had loads of problems, loads of bugs, very difficult to debug actually. And in particular what had happened was we found that we were making assumptions about VUFORIA that just weren't right. And so we really wanted to add tests for our matching code in particular. And this was our first test case, or at least this is the one that I wanted. The main point of the app. I wanted to test that if a user uploads a photo of a wine that's already in our database, they get back the right wine. So here we select the white wine and we get back the white wine. So I wrote this test. I don't know if it's big enough for you to see, but really it just adds two wines, two pictures of wines, and when I say add, that means, okay, well we upload a photo to VUFORIA, we also add the details to our database. And then we upload that one of those photos again, and we check, okay, that's the right one. It's a Blue Nun, my favourite one, I'm sure. But we hit problems when we wrote these tests, because, well, we were really at the mercy of the network. And that meant that if our CI system had a network glitch, any time within the few hours that it was running all of our tests, well, we might have a flake. And if a test is broken, we don't know that it's necessarily a flake. We don't know that it would have passed. But of course, even if the network was fine, let's say VUFORIA went down, or they went down, even just for a second, they stopped taking requests, there was a server error, something like that, our test again would be flaky. And another problem we hit was that VUFORIA charged per match, and it cost us quite a lot to run our test. People hit this all the time. Let's say you have S3 in the middle of your testing cycle. It can cost you a lot to store your test data there, even just temporarily. And even when we ignored all of those problems, even in the best case scenario, everything was really slow, because, well, they do processing magic. That's their task. Once you've uploaded an image, they try to extract features, all that kind of thing, for the matching later. And that can take a few seconds or even a few minutes for a large database. And we didn't want to have to poll and wait for a few minutes in our tests. It just took ages. So we named those tests that we had written, like the one I showed before, integration tests, because they tested the integration of everything. Our code, VUFORIA's code, sometimes even the iPhone app. And they were definitely useful. They definitely helped us find bugs. But what we also wanted to alleviate those problems I mentioned before was unit tests. And unit tests, although they have some downsides as well, definitely have a whole lot of benefits over integration tests. Because they can be fast, mainly. Really, what we want to know is, at least in part, does our code call VUFORIA correctly? And we want to know that even when VUFORIA is down, even when we're offline. And the nice thing about unit tests is that they can be very, very small in scope, or they are small in scope. So if one of them fails, we know exactly which part of our code failed, at least in the best case. And then a really cool thing about having very small scope, very fast tests is you can get tools to generate tests, things like hypothesis, which I think we've already had at least one talk on. So what we want to do is turn a code base which has integration tests into one which has integration tests but can also be unit tested. And one way that people do this is by using mocks. And mock is some code that provides the same interface as something that your code calls. So in our case, VUFORIA. but we want to reduce some cost by kind of copying that service. So, like mentioned before, the main costs we care about here were the time that it took to run a test and the flakiness. So my goal really here was that wherever the implementation code that was under test made a request to VUFORIA, we would be able to run our test suite and make sure that that request, instead of being piped to VUFORIA servers, were actually handled by a mock function. They were handled in memory. And we were using the requests library. I think it's pretty popular. And there's a whole bunch of ways with the request to say, okay, if a request is made to this address, actually, give me back this kind of data. The tool that I chose to use was requests mock, but if you look up how to mock the request library, you'll find a whole bunch. And this is an example of requests mock. This is a very simple case. You can see that, okay, well, if code within this context manager makes a GET request to test.com, then they'll get back data. And by default, 200 response and so on, some things in the headers and whatnot. And we also used another quite popular tool called PyTest. PyTest is a test runner, for those who don't know it. One of its nifty features is it gives you a really easy way, a neat way to have setup and tear down for tests that are shared among tests, and that's called fixtures. So the fixture that I've got here, it kind of says, okay, well, if I use this fixture, then requests made within the test will be within that context manager. They'll be run kind of at the point that it yields, and so all the requests to test.com will give back data, even though there's nothing special in the test add target. And you can actually be quite fancy with this. You don't have to just say it gives back data. You can give it a callable, so it can give back special things depending on the request, almost like you're kind of writing a little web server yourself, right? And what I did is I created just little mock functions for every VUFORIA endpoint that we used. And that mostly involved almost recreating VUFORIA's interface, firstly by looking at their documentation, but then also trying out trial and error. And I definitely didn't copy everything. I copied the things that we used, and I think that's quite a normal way to go about mocking things. But it's not like I'm rebuilding their business. I don't do the image matching, which is their core. It's most of what they spend their time on. So using that PyTest fixture, I could test our code without touching the real VUFORIA. And what that meant is that we can have unit tests. If you see this one is marked to use the fixture, it's very much like the other test before. It looks almost exactly the same, but now we're not touching the real VUFORIA. But even when we were using the mock, we hit a lot of major problems. And I guess one of the worst things that can happen when you think that you've got confidence in your test suite is that your tests pass, but you find that you have bugs in production, even of the code under test. It's very frustrating. And that did happen sometimes. And we found that when I'd been making the mock, just poking around, saying, oh, what happens if I give it this? What happens if I give it that? Of course, I inevitably made mistakes, and I'd copied the interface wrong. But even when I'd been very careful, even when someone else had reviewed that code, the mock code, and tested it themselves, what happened was, well, these web services, they don't promise often a stable API. And even if they do, they often don't adhere to those promises, keep those promises. So they made very minor changes, or what they thought were minor changes, that essentially broke our code, and we didn't know it because our mocks were conforming to the old spec. No release notes, no changelog. I think this is quite a common story. And it made it really hard for us to find out where does the mock need to be changed when we had a bug in production, but not in our mock, when we were using our mock. And I left the job in that kind of state of I guess, a little bit frustrated that the solution I built was just about okay. But I also kind of had a belief that this service VUFORIA could be really useful to a whole bunch of people if it weren't such a horrible tool to use programmatically, if it had a better interface. And I thought, okay, well, why don't I make a library? I could be, the VUFORIA library guy, and then if they take off, I can take off, kind of thing. I think some of us have those dreams. But I also started testing it out with the mock. But I had another aim. I wasn't just going to ship the library. I also wanted to ship the mock. I wanted everyone using my library to be able to test their own code without touching VUFORIA. And so I wrote some integration tests for the library, much like the integration tests we saw before. And I put the test suite on Travis CI. I think there's a whole bunch of these free for open source CI systems, but Travis CI is the one I know and I like. And one really cool feature of it, if you're testing a web service, is that it lets you have secrets. So you can say, these are my credentials. And they can connect to the web service, but it won't show up in the logs. People looking at the repository won't be able to see them. So I quite like it for that. So again, I'm writing the mock, but this time I don't want to make the same mistakes. I don't want the mock to be incorrect, and I don't want it to be correct only temporarily and then later outdated. So that's where we get to verified fakes. A verified fake is all about avoiding those problems. And what a verified fake is it's a fake implementation just like the mock, but this time it's verified against a test suite that also covers the real implementation. So I didn't have VUFORIA's test suite available. I don't know if they have a test suite. So essentially what I had to do, if I wanted a verified fake, which I did, was to make a test suite for their API and then apply that to my mock. And how did I make that test suite? Well, just like you would make a test suite for anything that you can't see the source code of or you don't understand the source code of. It's jiggery-pokery, it's, again, copying the documentation, but this time instead of saying the documentation says this should accept the number 1 and making my mock accept the number 1, I have a test. Test accepts the number 1, and so on. But of course, I didn't just test things that were in the documentation. I did my best at guessing at edge cases, guessing at what may they have missed, what should create an error. I wanted even to get the errors exactly right in the mock. So it's kind of like reverse engineering, but again, I don't have to worry about the hard bit, which is the image matching. And then once I have a test suite for their API, well, I need to make sure that the mock functions that I would make, I wanted to make mock functions that would also pass those tests. So PyTest has a feature which lets you parameterize fixtures. And what that means is that a test which uses those fixtures gets run once with each parameter option. So let's say in this simple example, we have a fixture which runs twice, one with the parameter true and once with the parameter false. And this runs before the test starts. It asserts that the parameter is truthy. So if I have any test that uses this fixture, well, it may or may not pass. It depends what's in the test with the truthy case, but with the falsy case, it's definitely going to fail. The assertion error will happen before the test even runs. So let's say if we look at an expansion almost of the fixture that we had before. This time it runs twice, the first time using the real VUFORIA and the second time using the mock VUFORIA. So that means that every test that I had for the API now runs twice. And I built up the mock until it passed all of those tests. Kind of like just test-driven development, really. So now the mock is a verified fake. So we've got to a verified fake. And what that means is that we trust, at least to some extent, that it's representative of the real VUFORIA, at least to the extent that our tests show us. So what we have is confidence that the tests that we write for the library are valid, or the tests that we write for any code that calls VUFORIA at least represents what would happen if you called the real VUFORIA. And so even though we might have just a few dozen, in this case a few hundred tests for the mock, we actually have a few thousand tests that can now run very quickly, run very cheaply, and so on. Only a small part of our test suite incurs those costs, when in the original case our whole test suite incurred those costs. But if you remember, we also had another problem as well as costs, we were worried that VUFORIA would change and that would make our mock inaccurate. So now, every time the tests pass, I know that the mock is still a faithful representation of VUFORIA. But of course, our tests only run when we make a change to the code. And that might not be often enough to actually spot changes in the API quickly. Maybe, we just don't touch this module for a few weeks, and our app is broken in production. So another reason that I like Travis CI is that you can set tests to run on a schedule. But again, if you remember, there's a cost associated to running them. So what you have to do is choose the trade-off, right? You have to choose how much can you spend, how much flakiness can you deal with, but also how long can you go without knowing that your mock is now not so useful, and therefore your code might break in production. So there's really a trade-off, and the trade-off that I chose for this particular project is to run them every night. But you can run them every week, or just before you do a release, or every 4 hours, just really whatever suits. So if we go back to an example of when I was working on that wine application, we didn't care about the physical width of each wine label. This is something that VUFORIA lets you tell them. We didn't care. So we just said it's 0 centimeters, whatever, who cares? And that worked, and in the mock that I built at that company, the mock accepted 0. And then, when I was building the verified fake, I had this test basically says, hey, if I give it 0, just make sure it's a successful response. And that runs against the mock every night and the real thing every night. And then one morning, I get an email from Travis saying, this build has failed. And I look at the logs, and it tells me exactly what has failed. Test 0 width has failed on the real VUFORIA, it's passed on the mock VUFORIA. So they differ. And that means that just within a few hours of them making an undocumented change, I know about it. My code can then be updated when I choose to do so to handle their new API requirements. And if I was still working on the wine application, I'd be able to fix something that was going to customers very, very quickly. Now I can change the library as well, and I can change that to give the same error message that VUFORIA does when they have a 0 width given. So I hope with that it at least shows some of the value of having a verified fake to a developer who writes code which integrates with any third-party software. People can write fakes for Slack if you're writing a Slack bot, or Twitter if you're writing a Twitter client, but it doesn't have to be necessarily a web service. So sometimes you might be using a file system that can't easily be run on your developer machine. You might be using a database that costs a lot of money or uses a lot of resources. There's all kinds of third-party code which this really does apply to. So now you can imagine that a big part of this, for me, as I explained, was reverse engineering, really writing their test suite for them. But if you have the original source code, and if you have a test suite for your source code, well then it takes out a huge amount of the work of making a verified fake. And in particular because a lot of the fake can even itself share code with the real implementation. Things like, what error do we give if the content type is wrong? That doesn't matter if it's just in an in-memory fake or if it's in my real web service. But very few of these web services that we rely on are open source. So what I propose is that if you're shipping software which people might want to call in tests, well, you can add tremendous value to that software by shipping your own verified fake. And it might even choose someone like me to choose your software over a competitor's. And if you make a verified fake as the author of the software, as I said, it's so much easier. And in the last decade or so, having an API for your web service has really become vital. Right? It's like table stakes. You can't have a popular web service almost without an API or an API coming soon. And so maybe we can hope that in the next decade, having an API that's really easily tested, perhaps by shipping a verified fake, will become table stakes as well. And again, you don't have to give your secret source away. VUFORIA, if they ship one, they wouldn't have to give their image matching code away. Twitter's API is fairly simple. What's difficult for them is scale. Their fake service doesn't have to scale well. And if you're shipping a fake, sure, we could do it like I did before and give everyone using Python and requests a fake, and actually quite a nice interface. But not everyone is using Python, not everyone's using requests. So what I wanted to do is to be able to make my mock accessible to everyone, whether or not they're using my library, whether or not they're using my language of choice. And one way to do that is to write the fake however you want to write an HTTP server in this case. You could use Flask, Django, you could use Java, you could use whatever you want. And then you can provide a Docker image and ship your fake as a Docker image. So now the people who want to use the fake can point their requests, which were meant to go to VUFORIA, meant to go to S3, meant to go to Twitter, instead at, let's say we could have a new Docker container for each test. Maybe that will get a little bit slow, but you can imagine the idea. Or they could use requests mock, or maybe they could just say, okay, well, we have a S3 base URL in our configuration, and under test we override that to be the IP address of a container. So that's my introduction to verified fakes. Thank you very much.
Thank you very much, Adam. Now we have a few minutes for questions, so if anybody has a question, I'll just get the microphone turned on. Okay, I think that's turned on.
Hiya. How much time did you spend writing the verified fake for VUFORIA?
I am not done yet. I have put 3 months into it so far. I would say about 2 months of full-time work, and it looks like I'm 2/3 of the way there. So it is an expensive project, even for a very small API. Maybe you could think, is that worth it? I guess it depends if it's the core of your business or if you find it very interesting, yes. And if not, maybe you can do verify just a subset of the API that you're mocking that you really need to work.
Hi, yeah, thanks for the talk. Just quickly, I'm sorry, but I'm not actually getting the full flow of what you're trying to do here. When you're doing your verified fake, how is that different from a mock as a general mock?
Oh, okay, sorry that I wasn't so clear on that. So when you make the mock, you're copying their code. And if you copy it incorrectly, you don't know. When you make a verified fake, you're copying it exactly the same, and you're adding a test that runs against the mock that says 0 is an accepted width, and you run that same test against the real web service, and so you at least know that your mock behaves in that particular way the same as the web service. So the code itself of the mock is basically the same.
Hello, thank you very much for the interesting ideas. You mentioned early on some of the downsides of running integration tests, like cost and reliability. How, I guess you still have those downsides with your mock verification tests, and that they will cost you money and that they may fail if there's downtime. How have you dealt with that, and have you found that to be a problem in practice?
So when you're running all of your applications tests as integration tests, that could be a huge range of things. At least if you just test the mock, then you're hitting those costs far less. And that's how I've attempted to deal with it. And you could say, okay, well, as I mentioned later in the talk, you only run those tests nightly, weekly, and you run the thousands of tests dozens of times a day for the rest of your application. So I guess the way that I try to deal with those costs is just by running those tests less often.
I think we have time for one more question if anybody has anything.
You've had your hand up for a while.
Thanks. So what other popular APIs have verified fakes available that you know about?
I'm not sure of any super popular ones, but the verified fake that... actually, sorry, that's wrong. I believe that SQLite, I'm not sure how to pronounce it, has an in-memory option. I think you can do SQLite :// memory, and then everything happens in memory, and that's super useful for your tests, and that behaves, I believe, just like SQLite on disk. Also, the inspiration to me came from a tool called Mimic, which is a verified fake made by Rackspace using Twisted for a whole bunch of their cloud services. And so if you want to if you want to test your code that integrates with the Rackspace services, you can do that with a Docker container that you spin up on your machine or on your CI system.
That's all the questions we have time for, but Adam is around for the rest of the day, so if you do want to ask him anything else, please do come and find him. In the meantime, please join me again in thanking Adam for an excellent talk.